Hi everyone, welcome back to Lulumath. This video is about adding polynomials, and you'll need to know about like terms and writing a polynomial in standard form or in descending order, and both of those videos are available at lulumath.com or on the Lulumath YouTube channel if you need a refresher before you watch this video. So if you see here, we are asked to simplify the quantity 4x squared plus 5x minus 2 plus the quantity 3x squared minus 12x plus 1. So our brackets or our parentheses serve the purpose of grouping things together. And it's useful especially if we need to distribute something through. But if you look at this example that we have here, this 4x squared plus 5x minus 2, there's nothing that really needs to be distributed through. So we're saying that this is grouped together, but there's nothing that is being multiplied through, so I don't technically need these brackets here. And then if I look at this 3x squared minus 12x plus 1, this is also grouped together. And again, there's really nothing to distribute. We do have this plus sign in front, and technically we also have a plus sign in front here. But when we distribute a plus sign, nothing really changes it at all. So in an example like this, brackets aren't really necessary. So I'm just going to copy everything down again without the brackets. Now I'm going to look and see, do I have any like terms? And just a reminder that like terms must have the same variable with the same exponent. So looking here, we have 4x squared. The variable is an x and the exponent is 2. And if I look at all the remaining terms that I have here, this 3x squared has the same variable and the same exponent. So those can be grouped together. Now I can just add them together. If I have 4x squared and another 3x squared, that means altogether I have 7x squared. Looking at this 5x that we have here, are there any other terms that have just an x with it as well? This negative 12x has x to the power of 1, just like this is 5x to the power of 1. So those are also like terms. So I'm going to collect a positive 5, and this is a negative 12. So 5 and negative 12, when I put them together, gives me negative 7. So I get negative 7x. And then lastly, we have this negative 2 right here. And it's like this one, these are constant terms, so they can be put together, and negative 2 plus 1 is negative 1. Now, a couple things to note. First thing is, we need to make sure to write the final answer in standard form or descending order. The other important note is, when collecting like terms, we do not want to add the exponents. We only add exponents when we're multiplying. We're just collecting like terms. So in the instance here where we have this 4x squared and this 3x squared, because we are adding, we are simply saying that we have 4 sets of x squared here. And here we're saying that we have another 3 sets of x squareds. So altogether, what this is saying is we have 1, 2, 3, 4, 5, 6, 7 x squareds. So be careful about that. And this will be our final answer, okay? Okay, in our next example, again, we have 2 sets of brackets, 2x squared y plus 9xy squared minus 5xy, and then we have 7xy squared minus xy minus 11x squared y. Now, we could distribute the plus sign in front, but distributing won't change anything in our problem here. And it's essentially multiplication by 1, and 1 doesn't change anything at all when we're multiplying. So I'm going to rewrite this without our brackets. And here's where things get tricky. Make sure you're extra careful about what terms are actually like terms. So here we have 2x squared y. So we're going to look for any other terms that have an x squared y in it. So for example, this 9xy squared right here is not a like term because the squared is on the x here, but the squared here is on the y. This is not a like term because there's no squareds at all. This is not a like term because, again, it's y squared versus x squared. Same thing, no squareds here, so not a like term. This is a like term because x squared y is what we have here, just like we have x squared y here. So if we start with 2x squared y's and we take away 11 of them, 2 minus 11 is -9. So I end up getting -9 x squared y. Now, for my next set of like terms, I have 9xy squared, and the only other term that has an xy squared on it is the 7xy squared. And when I add 9 and 7 together, I get positive 16. So here I get plus 16xy squared. And then I have a negative 5xy, and that's like this negative xy, which has an invisible 1. So we're putting together negative 5 and negative 1. And negative 5 minus 1, or negative 5 plus negative 1, is negative 6. So I end up getting negative 6xy. Now let's talk about descending order. Here I've got x squared y to the power of 1, and here I have x to the power of 1, y to the power of 2. So altogether my degree here is a third degree, and here my degree here is also a third degree. But here I've got x to the power of 1, x to the power of 1, so my degree here is a second degree. So that means that these two terms have equivalent degrees. So either way will work. I could put the negative 9x squared y first, or if I wanted to, I could put the 16xy squared first. Because when they have the same degree, it doesn't matter which one goes first. And this is one of my two possible final answers here, this being the other final answer. Okay, in our last example, we're asked to simplify this example that we have here. Now here we have 3 separate groups, but again, each time we're just distributing a positive 1 through, so that's not changing any of my terms, so I can rewrite this without my brackets. So the first term I have here is 5a, and I'm going to look for any other terms that might have an a in it. So looking at all of my terms here, I see this negative 10a is like the 5a. 5 minus 10 is negative 5, so I'm going to write down here that this is negative 5a. Beautiful. Next term I see here is negative 9a cubed. I'm going to look and see, are there any other a cubed terms here? And I can see that I have positive 12a cubed. So negative 9 plus 12 is positive 3, and my a cubed stays the same. Then I see I have a positive 3a squared, and looking to see if there are any other like terms, that with the 3a squared, we have positive 1a squared and minus 12a squared. So this 3 plus this 1 is positive 4, and then positive 4 minus this 12 is negative 8. So I will say negative 8a squared. And then lastly, I see here that I just have this 6. There's nothing else like it, so I'm just going to copy down that plus 6. Now, don't forget to make sure to write your answer in descending order. So if you see, my highest exponent is this 3a cubed, so I will write that down first. Then the next highest exponent is negative 8a squared, so that will go next. The next highest exponent after that is this negative 5a, so I will write that down next, and then the plus 6 goes at the end, and this is my answer. Now, if you want to save yourself a step, you can initially start by collecting your like terms in descending order. So instead of starting with this 5a here, we can just start with this 9a cubed here, and then collect that with this positive 12a cubed and put that together and go in that order. Whatever you prefer, whatever makes the most sense to you is totally up to you. That's it for this video. If you have any questions, please let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to share with others and to subscribe. Thank you for watching. Have a great day, and we'll catch you next time. Bye.